Ladies and gentlemen, please welcome Professor Wang Ming.
Well, a very good morning to all of you. I would like to thank Randy, Joe, Mark, as well as Igor for inviting me to speak in your first seasteading gathering. I'm indeed privileged to be in such a beautiful environment. It's like paradise on earth. So you have chosen a very, very good site for your first floating islands. Okay, I'm in the area of very large floating structures for the last 20 years. And I've been dreaming about these floating islands for a long, long time. And it's so good to see that we are at the verge of creating such a floating structure. Now, you should be able to animate, but it looks like it's not animating. This is a floating jetty in Krabi. And actually, if it could animate, you could see the movement of this floating jetty. So we can create floating structures to behave like a wave if you wish to. And it's quite interesting. Okay. First, I'd like to point out two factors that I believe eventually all of us will embrace floating structures as part of our development of the cities as well as the use of space. The first factor is that we know that the world's urban population is expected to rise to 5 billion by the year 2030 as people flock to the cities due to jobs prospects, due to better food, better medical facilities, as well as a lot more fun and excitement in cities. In 1800, there's only one city above 1 million, and that's London. Then there are 16 cities in 1900 that go beyond 1 million, and today we have more than 400 cities that are more than 1 million. And our population in the cities actually increased dramatically. In 1970s, we talk about big cities of 20 million. But in 2015, right now, cities have reached 30 million, and it cannot keep on going at this rate. It's become unsustainable. So if you look at the little photos down there, you can see the cities are so crowded, and from a bird's eye view, the people are like ants all over the place. It is not a comfortable kind of lifestyle to be in such a crowded environment. And the second factor is that because of the effect of carbon dioxide emission, we are seeing a lot of changes to our planet. Of course, ocean acidification leads to the coral reefs being completely destroyed and less productive fisheries. And then the other point about carbon dioxide emission is that it leads to greenhouse effects that warm up our atmosphere and leads to thermal expansion of our ocean, and therefore a sea level rise. We witness larger hurricanes because of the great amount of energy that it picks up from the warm oceans before arriving on land. And there will be more evaporation leading to greater floods and rain, and oceans become less productive, leading to more and more expensive fish if we want to eat them. So these two factors, the densification of cities that are usually found on the coastlines as well as on riverbanks or water bodies, leads to a significant rise in land costs. It makes floating structures now become very, very economically viable. And at the same time, the carbon dioxide lead to rising water level and a disappearance of low-lying coastal areas and small islands. So with very high land costs, very large floating structures become a very economical and sustainable solution for creating new land from the sea to east congestion in coastal cities and small islands without the fear of rising water level due to global warming. In fact, we have so much water space. 70% of the Earth's surface is covered by our ocean and seas. Okay, in today's talk, I'm going to tell you a little bit of what is involved in a floating structure and what we can do with floating structures. What are the present applications and future applications of floating structures? Now, basically, there are two main types of floating structures. One type is called a semi-submersible type, where the platform is raised from the sea level, water level, by columns that give you the ballast. And these are deployed in very high seas where the waves are very, very strong. So if you want to build in the high seas, you need a semi-submersible type. The other type, which is cheaper, you don't have to have the column tubes and so on to lift the platform. The platform just lies and rests on the surface of the water, and that's called the pontoon type. It's very, very economical, and it deployed in very calm seas, such as in a lagoon, cove, or harbor. Okay, so what are the components in a very large floating structure? For a large floating structure, you need a mooring system. The mooring system keeps the floating structure in position. It restricts movement in the horizontal plane, but it allows the floating structures to move in a transverse direction, allowing for different payloads as well as tidal variation. At the same time, you must get some access to your floating structure. You need, if it is very close to shoreline, you can have an access gangway or linkway. But if it is further away, we can build a floating road or floating bridge to your structure. However, if it is much, much further away, you need to create a berthing facilities for your boat and ships to come by to supply your floating structure and also to remove whatever waste and supplies from the structure. I just want to show you the different kinds of station keeping system. You can have a very simple station keeping system using chains, ropes, and anchors and sinkers. But this will allow the floating structures to move considerable because it is free to move with the water currents. The other type is inspired by the tension leg platforms. You can have tethers that goes down to the hard rock and using anchors or torpedoes, pawls, to hold the floating structure. So it's like inverted pendulum. Of course, unfortunately, it doesn't come out that well. There is a caisson, which is a rectangular block. It doesn't show up in this diagram here. Caissons are just big boxes that are floated out to position. The seabed is being treated and is sunk in place to provide that reaction wall so that the floating structure can be kept in place by this caisson, dolphins, and rubber fender system. If your seabed is not hard at all, you need to use the jacket pile type fenders. Unfortunately, the diagrams does not show up that well here on this picture. Let me show you how it looks like. For example, you could have the jacket pile underneath the water. You can see something like that with a collar and a mooring dolphin head to hold the floating platform in position. Now, the rubber fenders are critical because it allows the absorption of the horizontal force due to the current as well as the wave and the wind on your floating structure. The rubber fenders are not cheap. Some of them are about $200,000, but it can last 30 years. But it is essential for very large floating structures to keep it in place and to absorb the energy so that your mooring dolphins are not unduly huge. What are the advantages of very large floating structures over the traditional land reclamation? First, it is very, very economical when you're dealing with deep water and soft seabed. Now, when I talk about deep water, I'm talking about 25 meters and beyond. Anything 25 meters and beyond, it is not possible for land reclamation. Your costs a bomb, and in fact, you can lose your whole assets and resources if trying to reclaim very deep water. And soft seabed is also dangerous. When you reclaim, the fill material just sink deep into the ground, and it'd be incredibly expensive to do land reclamation. Also, very large floating structure has very, very little effect on the environment, such as the sea current and water quality. It's almost transparent, allowing any flow of water and sea current below it. Also, very short construction time. You can build very large floating structures within months, whereas land reclamation, you need many years before you can build anything on it to allow it for consolidation. It can take any plane shape and cutouts. Your floating island can be of any shape you wish. If you wish to have the shape of your face, we can do that as well. So that's no problem whatsoever. And it's expandable and removable, allowing you to free up sea space if you want to. Business is good, you expand it. great against seismic action because it's base isolated, so it's immune to seismic action. It utilizes buoyancy force to support the load, so that is a free, nature gives you a free pass for this. If you look at the troll on this particular picture here, you can see that this troll is about 372 meters of height. It's about 168,000 tons. You can move such a huge structure on water free of charge. If you were to use a crane or rail or whatever on land, it will cost you a bomb to move such a huge structure. Also, it possesses mobility. You can tow it away in any location. For if you've got a desalination plant and that area is contaminated, you can move your floating desalination plant to another area. Easy access to water, so make full use of that easy access water for your applications. And the interior space may be utilized for storage, for sewerage systems and so on. The presence on coastline serve as breakwaters to protect your shoreline, as well as it is not affected by global warming at all. It's like Noah's Ark. It just floats with it. So I want to show to you some interesting application of very large floating structures. Not known to many people, the Americans built a floating airfield during the Second World War to provide a platform for damaged aircrafts to land if the aircraft carrier is completely destroyed. You can see one of those aircraft landing on this strip here. And then, the Japanese, in the year 1995 to 2000, initiated a program to study the feasibility of a floating airport on the sea. They built this mega float, which is 1 kilometer long, and the width varies from 60 meters to 120 meters. Completed within 3 months for construction-wise, moored in the Tokyo harbor and study aircraft landing and see whether the devices are affected by the surge, pitch, and roll of the structure. When I stepped on this mega float, I was amazed. It's almost like stepping on land. You can't even feel a thing. It's just like a fly on the back of an elephant. Would an elephant know that there's a fly there? Absolutely not. That is how it is. The bigger your floating structure is, the more stable it is. It's almost like land. And it went into Guinness Book record as the largest floating island, man-made island. Floating bridges and roads are everywhere. King Sextus, the Persian king, marched his troops to Europe to try to conquer Europe. And they tied 300 boats to form a floating bridge. He built 2 of them and marched over 100,000 troops. The Norwegians used their offshore technology to build floating bridges across their fjords, which are very, very deep. Fjords are 300 meters to 500 meters, impossible to peer down. So they are building this very, very interesting floating structures, very, very elegant. For example, the Bay-Swan Bridge uses the flexibility of a connecting rod to move up and down under tidal variations. It rests on 6 concrete pontoons supporting the bridge deck and, of course, the roadway on top. Not known to many people also, during the Second World War, the British built the Mulberry Harbour, 6 miles of steel floating on concrete pontoons and steel pontoons to land troops from the ship onto the Normandy beach. Of course, Dubai have the floating bridge. Americans have built these huge, massive floating bridges in Seattle, and they are going to start work in this coming June this year on a floating railway bridge. It's going to be great. And in Netherlands, in Japan, they've built the largest, the longest floating steel arch bridge that spans between 2 reclaimed islands. It's called the Yumema Bridge. This bridge is about 400 meters, rests on 2 pontoons, and you can see the silver lining at the bottom of the pontoons. These silver linings made of titanium plates at the splash zones to prevent corrosion. It is able to swing on one pivot here, and the reaction walls can be opened to allow tall ships to pass through if need be. I'm speaking a bit fast, sorry, because of time. And there are also ideas of submerged floating tunnel and so on, because the fjord's been very, very deep. Using such technology will save a lot of cost. And in the E39 highway that Norway is building to link from top to bottom from north to south of the country, they're going to have several of these floating bridges as well as floating tunnels. You could use a subsea tunnel, but then you would mean a long, long distance, because you just can't have a very steep road going down. You need some gradient. But if you have this subsea tunnel, you can shorten it by considerable amount. This is going to be a very exciting project that will come on stream shortly. Floating structures have been used for piers. The Eugenia piers, concrete pier of 150 meters by 30 meters, 4 meters in depth, has been in operation for 20-odd years without any maintenance at all. And then in Korea, Incheon, they have built 2 floating cruise pier, one in concrete and one in steel, to demonstrate to the world the capability of building floating structures. And then they have, of course, in Alaska, you have the floating terminal dock and so on. And Norway is going to build the floating dock as well as cruise center for cruise ships that take tourists to see the northern lights. Okay, I want to show to you also very large floating structures can be used for aquaculture. There's a lot of fishing farms right now all over the globe, and all of them are very near shore. Some of them are inside the bay, leading to a lot of problems with pollution and so on. So there are now steps taken to try to move these floating fish farms up offshore, where there will be no problem with pollution. And some of this, for example, the Norwegians have built with Sintef has built this cage, which is about 100 million US dollars, and it can house 1.2 million salmons. One salmon, you can sell it to the wholesaler for 10 euros, so it's about 12 million euros per cage. So the cage better don't get damaged, because if they do, they just lose $12 million at one go. And there's aquaports in Hawaii, and they are looking at all these projects. In Norway, when they farm the salmons, they discover they're also farming sea lice, and the sea lice are eating the salmons up. So what they're doing is that they are building concrete tanks and put a riser down there and bring water 14 meters below the water level so that there's no sea lice, continuously pumping it so that the fish can have fresh water. But it's costly to farm in an area where there's sea lice. You have to protect your salmons, and they are selling like hotcakes in Norway. Everybody's having these concrete tanks instead of these usually circular floaters with nets below it. Now they're even building bigger ones, the shape of their bathtub. Exactly, you look at your bathtub, exactly that's the shape that they're building one. And then fish farming, and Barcelona-based forward-thinking architecture has been very strong in this area, and they have come up with ideas of how we can use fish farming, hydroponics, and renewable energy, putting there to provide food. Also, very large floating structures can use for energy generation and storage, which Igor has already alluded to. Floating nuclear power plants will become very ubiquitous in time, because I think as nuclear energy becomes safer and safer, we can use that. In fact, we have already nuclear submarines and nuclear-powered aircraft carriers all over the world, and they are floating and calling at their ports. Now, we also have floating solar farms. In Japan, they are built in Kagoshima, 70 megawatts of floating solar plant. It is great because out in the sea, there's no shadows, you get a lot of sunlight, you can generate a lot of electricity, and every country is now moving towards floating solar farm. England is going for it, India, China, and so on. Now, also we can store fuel in the sea. Fuel is lighter than water. We can store in the sea, provided we provide a skin to hold it. In Japan, they have built these huge modules that can house, they are huge, something like 400 meters by 80 meters by 25 meters, and they can house 5.6 million kiloliters in this kind of 8 modules as storing oil base. And in Singapore, right now, I'm working on the floating hydrocarbon storage, where we, instead of having a huge module and separated by different compartments, we individualize each tank. But the difficulty is how to get these tanks to be self-stabilizing. In other words, with the tilting and sloshing, it should be self-stabilizing, and we came up with a very, very good design, which we have patented. I do not have time to talk about this, but if you'd like to know more, I can discuss with you. And you can see huge floating concrete platforms for storage and as well as hydrocarbon production. Also, it has been used as a drone to receive the rockets. SpaceX used it and demonstrated its capability. Vincent Calibert is a great architect. It's a Belgian headquarters in Paris, good friend of mine, and he has come up with this idea of why don't we build a whale-shaped floating garden that will just go all over and drift in the rivers, collecting and all the garbage, and as well as treating the water using biofiltration. Also, floating structures can be used as wave breakers, as well as windbreaker. And this is the project I'm starting in University of Queensland, where I'm going to use a system of arches from a plan view to keep the concrete in compression, and using sloping platforms to allow the wave to run up like a beach to exhaust its energy, and also with tubes that allow water to get in and letting the water to spill back onto the incident wave. So this is something very exciting, and if it works, it could be deployed. We can use a series of arches, one after the other, to break the wave at different levels. I want to show to you that you can use floating structure for this kind of, I'm not sure whether there's sound. There should be some music. In China, they've built a very, very large floating walkway. You could consider this, and it will attract millions of people to come to visit you. It's on the Hongshui River. And you can have sea shows, night shows, exhibition centers. You can create something magical for the world. So just think big, just think bold. Okay, I'm sorry. I'll continue because of lack of time. I'm also involved in this floating wetlands project in Singapore. And what we want to do is to create biodiversity in the rivers. And so when you have a sterile river, there's nothing much happening. We can build this floating wetlands comprising HDPE, high-density polyethylene modules, about 1 meter in diameter, so that it's lightweight and people can carry it. And inside there's foam, and then you have a hole there for the plants to go through. And these river plants also serve to clean up the river water. And we can create all these islands, marshland, to make it very, very exciting on the rivers. And in Seoul, they have built these floating islands and bring a lot of activities to the river. So the exhibition hall, they have galleries and all that stuff. And then in Norway, Oslo, in Stavanger, first it was a rundown warehouse, and that has been converted into a high-rise apartments, and a lot of young professionals, Norwegians, love to stay here because they created a very interesting artificial beach. And this artificial beach on the platform, you can see it's been built and towed to site, and create a wonderful beach in the midst of, in the midst of the city. You can create beaches, if you like, in places where it's not possible, using floating platforms. Also, there are floating restaurants and hotels all over the world. You have Four Seasons Hotel, you have all this jumbo restaurant. This is one of my proposal, a floating crab restaurant. And seasteading is feel free to use this idea. What I'm going to do is that I'm going to use the roof loads to be carried out by the mooring dolphins here. so that the entire floating platform is free from carrying the roof loads. So you can have uninterrupted space of 50 meters by 50 meters without any columns. And you can put your dining area and give the people a very, very nice experience. You can use this idea of using the mooring dolphins as your supporting points for your roof loads. I was involved in this very large floating performance stage in Marina Marine. This is about 120 meters by 82 meters by 1.2 meter. And it's been loved very much by Singaporeans. All the time they enjoy the parade and the shows down there. The German says, why not we build a floating stadium? Each time we have a World Cup, we have to build a stadium. Why don't we have a floating stadium that can be moved to the location? Also, Maldives have come up with a floating golf course and as well as floating hotels. Now, French Polynesia should not be outdone by Maldives, right? You're going to do something even greater. Okay, people have been leaving on water. Oh, sorry. Okay, right. So I just want to say that I'm so proud to see seasteading leading the way to form the first world's floating city. I'm excited. I want to say that it's not a dream, it can become a reality. And there was a Norwegian saying that, which I like very much. The saying goes like this: because they say it's impossible, and that's why we do it. Okay, so I just want to terminate here by saying that the world's map will be very, very different in 50 years' time. New countries will be formed in the ocean, and a lot of floating structures will be crept up in all these islands. So thank you so much for your kind attention.